Hello friends, welcome back to the channel if you Codify, and today in this video we are going to talk about a JavaScript concept called closure. There are various way of explaining the closure concept on the internet, but the one thing is common about uh, accessing the variable out of the function scope. So here this statement, let's read this statement. A closure is the combination of function bundled together or enclosed with the reference to its surrounding state. In other words, a closure gives you access to outer function scope from inner functions. So basically closure is a powerful tool, I can say, to give you a very let's see an example. In the example we'll try to see how what kind of problem it solves. Okay, because understanding the closure by definition is not very sufficient, or let's try to understand it from a example. So here our requirement is to, let's say we have a function called uh, add. Okay, and what we want to know like how many times this function got executed. So as many times it gets executed or it got called, we will increase the number of the counter. Okay, so uh, let's say we can define a counter. Okay, and we can increase the counter here. Okay, and we can console it, console.log counter, and we can return from here also the counter, or we can delete. Okay, so it's going to increase the counter. So let's try to call it add and run it. I have to define it, the initial value of it. Okay, okay, now call it another time. Two. Obviously it's working fine, it's looking fine. Okay, but here the problem is here the problem is uh, this is not a secure function. This is not a secure function is because any other function can easily change this uh, the value of this counter, huh? Let's say we have another function, or unknowingly, or maybe, yeah, uh, without yeah, unknowingly, to some function. Okay, and it was working for some reason and set the value of counter again 0. Okay, and after 2, and this function called execute. Okay, what is that function? Some function. So now let's see what is going to happen. You see that, so you can understand that the result is coming 1 2, and because the value of the counter was got set by default, I mean by mistaken, to 0, some function setting the counter value to 0, so that's the result is going corrupted. Okay, so this would not, we can't say this concept is secure for our requirement, like how many times the add function is got called. Okay. Another thing what you can think is, but the another thing what we can try is, can we take this inside? Sorry, I'll remove this. Can we take this global value inside the function itself? We can take, but what the result is going to happen every time the counter will be set to 0. So remove this. No, not required now. So what will happen every time we will get the value only 1. See, so that is also not solving our problem. So what we can do next? The challenge here is, what is the requirement? The first requirement is that we can say the first requirement is that the counter value should not be, or should initialize only once. Okay, and the second requirement is what? um, the counter value should be increased on each call, right? So if you have seen the previous video, you might have seen a function called self-invoking. Okay, before going to that, what we need to do is here, mm, let's try to do this. Let's create this a new function inside the function, that is an inner function. Okay, function increase, or what we can say, let me call it inner function. And in that inner function, uh, we are writing the logic of increasing and value returning the value of this counter. Okay, so here what's going to happen? Mm, this initialization will not happen again and again. Okay, if we are able to call this function, this initialization will not happen again and again, and will be incremented on each call. Okay, so uh, let's try to do something. Let's try to see some output what we are getting. Console.log, and we are returning nothing from here, add function. So try to do one thing. We can return it. We can return the function itself, and this function return the final value. Okay, so try to call this function here. What we are going to get? The function. Okay, so let's do this. Const result is equal to, or let me call it inner function. Okay, is equal to, what is this? Add. Okay, now call this inner function. So what we are going to get? The value 1 y 2 times. Anywhere else something printed? Okay, here. Okay, so we are printing here 1. Let me call this again. What is going to happen here? You see this? You see this? Did I print it 3 times? Oh, maybe not saved. Okay. You see this 1, 2, 3. So here, what is happening is uh, this function this function is able to see this function is still able to modify the the value which is in the scope of the outer function, or you can say it is this function is able to access the value which was initialized in the same context. This function belongs into this context, right? This is a context, this is a scope of this add function. So this inner function sharing the same context of this variable. Okay, but you can see this is not only this is out of this scope. This value is the outer scope from this function. So this kind of problem we can solve through this closure function, not the closure function. It's this way, closure concept. Okay, thank you.